This is a prediction interval problem. Over the years, it was noticed that the cost of a slice of pizza and the cost of subway fare in a certain city seem to increase by the same amount. Let x represent the cost of a slice of pizza and y represent the corresponding subway fare. Use the following statistics that were obtained from a random sample, the cost in dollars of pizza and subway fares, to construct a prediction interval estimate for the subway fare with 95% confidence when the cost of a slice of pizza is $1. So what you would have to imagine is that we had a table of x and y, where x is the cost of pizza and y is the subway. And with this data that was given, they came up with these statistics. So we had 6 samples. They got B0 and B1 and x bar, the sum of x squareds, and the standard error of estimate, S sub e. So for us to find this prediction interval, what we need to do is we need to figure out what our y bar is and what our margin of error is. And with that, we would need our formulas. Oh, I'm sorry, this is y hat. Y hat is what we're looking for. So let's take a look at the formulas that we're going to need. To find y hat, we need to take a look at this formula where we have b sub 0 and b sub 1 given. So let's take this and use that formula to figure out our y hat. So we have y hat is b sub 0, that's 0.03456, plus b sub 1, 0.94502, and times x. The x in this case that they're referring to is the point that we want to use to make our estimate, and that would be $1. Alright, so in our calculators, we would punch that in. We would simply look for the b sub 0 is 0.03456, and then we want to add b sub 1, 0.94502. Oops. This is a 0.2. And then we have times 1. Now we don't have to do the times 1, but in case it wasn't equal to 1, you would put that x, whatever that x value is. So this is going to give us our y hat. So, sorry, I lost it. That was a 0.97958. 97958. So we have y hat. Now we need our margin of error. So to find our margin of error, it's actually a long, complicated formula. So let's take a look at that formula. Our margin of error is given by this t sub alpha over 2 times s sub e times the square root of this big long thing. So let's just copy that over and put that in our notes. To find our prediction interval, we need this formula. So let's see what we have here. We have, or what we need is, we need our t sub alpha over 2. So how do we find that? We look at the 95% confidence, and we know that n is equal to 6, so our degrees of freedom will be equal to 6 minus 2, which is 4. And with 95% confidence, we're looking at two-tail with 0.05. So let's look at our table real quick. This is a piece of our t distribution table. The area and two tails are 0.05, and our degrees of freedom is 4. So it looks like our critical value is 2.776. So let's start off with that. So margin of error is equal to 2.776. Okay. We have S of E, 0.123. Okay, a big square root here. 1 plus 1 over n is equal to 6, plus big fraction bar with our n, that's 6 again. X naught is the x value that we're given, and that is 1 minus x bar, that's 1.0833333, and we square that. So that's the numerator of this fraction, and then we have an n, and then now in this parentheses is the sum of x squareds. So the x squareds are over here, 9.77, minus the sum of the x's, and then we take that and square that. So that's 6.5 squared. So it's all here, it's just a matter of putting it into our calculators now. So let's see if we can take our calculator out and try to be meticulous with this input. Alright, so we have a 2.776, and then we have a times, and then we have a 0.123, and then another times, and now begins our big square root. So the square root symbol is on top of the x squared bar, so that's a square root, and then we have a 1 plus 1 over 6, so that's 1 divided by 6, plus, now this next step, I think it'd be good to use parentheses, but I think we can get by without the parentheses for the numerator. But the denominator, when you're doing this, you got to make sure that you consider a big parentheses around the denominator. So the numerator, you don't need a parentheses because you'll have 6, and then you'll have a built-in parentheses with a subtraction. So that'll be okay. Alright, so we're at this point, we have a plus, and then let's start with a 6. And then times, you can press the times or you can just put parentheses. And then here we have the x naught, which is 1, minus, and then the x bar, which is 1.08, and then 33333. We'll close that parentheses and we'll square it. And then we have a divide. So this is now where we're going to open up a new parentheses for our n. So let's open up new parentheses. Oh, n is equal to 6, by the way. This should have been a 6. 6 times 9.77 minus 6.5, and then we're squaring that, and then close the parentheses to close the parentheses for the denominator. And so this is the end of your square root. We can press the right arrow to get out of it, or we can just press enter to get our value. So after that calculation, your margin of error is, let's go to, we want the final answer to 2 decimal places, so we need at least 3 decimal places for this. And so that would be 0.3692. Let's go for 0.3692. So that is our margin of error. And we want our prediction interval to look like this. So we have 0.97958, and then a minus 0.3692, less than y less than 0.97958, and then a plus the margin of error. So let's see if we can do this in our calculators the easy way. We have, actually, this is the margin of error. We can just punch that in the calculator or put it in the memory. Let's just say this is, well, let's just punch the whole thing in our calculator. So starting with 0.97958, and then a minus the margin of error, 0.3692. So this is going to be the left endpoint, and then the right endpoint is the same thing with a plus. So instead of typing the whole thing, a little trick to get the last entry is a second function and enter, and then just move your cursor to the minus sign. You want to change that into a plus, and then press enter again. So we have the two decimal places, 0.61 to 1.35. So your margin of error would be 0.61 less than y, or your prediction interval would be 0.61 minus is less than y, which is less than 1.35. Okay, so that is how you can find the prediction interval given the statistics already worked out for you without the original data set.